Okay, so here we are again. So I was looking at my schedule. It looks like we've decided to do the chapter 6 problem set next Monday and the sample midterm next Thursday. Okay, so Monday we'll go over the chapter 6 problem set, and then now we had to do it in this order because we're not quite done with chapter 6, and of course chapter 6 is on the first midterm. So today we should be done with chapter 6, and when we're done with that, then we can do the problem set. And when that's done, then we can do the sample midterm. And then when that's done, we can do the real thing. Okay, now the actual midterm will be a take-home exam, of course. You'll be able to download it off of Moodle. And what you'll want to do is write out your answers, probably by hand. And when you're done, you can either use a scanning software on your iPhone, or else just take pictures of it with your camera and then email them back to me at my purchase address, alananderson@purchase.edu. And the reason why it's easier if you send it there is because it's a much smaller account. I have a lot less messages in there. It's just easier to keep everything organized. All right, well, in the meantime, then we have to finish chapter 6. Okay, now we weren't completely done. We're getting close. We're getting very close, but not close enough to start the problem sets just yet. So that's why this schedule was chosen. So let's get out 6, and let's see where we left off. I think we're ready for factoring. Now, remember, we're looking at what we call quadratic expressions or equations. Now, a quadratic equation is written in the following form: ax squared plus bx plus c equals 0. Now, what's happening here is that what you're looking for are solutions, which means the two values of x where this function crosses the horizontal axis. You can see on this picture here, x1 comma x20 are the 2 points where it crosses, and it's the x1 and x2 that we're looking for. The fact that there is an x squared in this equation guarantees that there will be 2 places where this happens. And you'll also notice that this graph, it takes the form of a parabola. All quadratic equations can be described with parabolas. The only thing that really separates one from another is whether it's facing up or down. This one happens to be facing up because a is positive. If a was negative, it would be facing down. But other than that, it must cross at these 2 points. So our job is to figure out where those points are. Now, there's a couple of ways we can do this. One of them is a little more, I don't know, I think it's a little more awkward, and it only works under certain conditions, but it's important to understand what this is all about. Then we're going to move on to something that you've seen before, the quadratic formula. The beauty of the quadratic formula is that it always works, no matter how complicated this expression is. Factoring really only works well with very simple cases. In particular, when a is equal to 1, factoring is pretty straightforward. But for other cases, it doesn't work nearly as well, and it can be a very time-consuming process. So we'll start by reviewing what factoring is and see how it works. And then when we're done with that, we can revisit our old friend from high school, the quadratic formula. Oh, yeah, so in other words, if you missed it, we're still not quite done with chapter 6. The midterm is based on chapters 5 and 6. So when we're done today, what we're going to do is next Monday, we'll go over the chapter 6 problem set. And then next Thursday, we'll go over the sample midterm, which covers chapters 5 and 6. And then I'll post the actual midterm on Moodle. And you can download it and work on it. And you can have about a week or so to do it. Not that you'll need it. It's not nearly that long. But just in case, if you want to spend a lot of time reviewing your notes or watching the videos or whatever, you certainly can feel free to do so. And so next week, we'll go over more of the details, but basically you'll have plenty of time to finish it. And you'll have the ability to look through all your notes and everything you've written down and the slides and whatever's on Moodle. So it should be pretty straightforward. All right, so yes, I guess you did miss an important first minute. But so that's what we were talking about. Okay. So today we're just going to wrap up chapter 6, and then if there's time, maybe take a peek at chapter 8. All right. So anyway, solving a quadratic equation with factoring can be done in the following way. Now, it sounds a lot more complicated than it really is. So in other words, describing this in English is a little bit awkward because, it's very difficult to describe what we're doing. So what we're going to do is this. We're going to start with a quadratic equation like this one. And so what we're going to do is notice that what we're trying to do is decompose it into a product of two binomial expressions. Now, I did mention before that factoring is very straightforward when this term, this is A, by the way, A is 1. Oh, how did that happen? I don't mind having purple, but it doesn't show up as well on the screen, I don't think. So that's why I usually stick with black. So remember, this is ax squared plus bx plus c equals 0, which again implies some kind of parabola which crosses the axis twice. And we're looking for those 2 points. And it turns out what actually will happen here is if you find x1 and x2 and substitute them back into this equation, they'll both give us a value of 0. So here, there's an implied 1 here. So in other words, in this expression, a equals 1, b is -3, and c is -4. Now, for factoring, these letters don't really matter, but what does matter is that when you have a equals 1, the factoring is fairly straightforward because the first term in each binary expression is guaranteed to be x. So we can focus all of our attention on the 2 constants that we need. And let's just arbitrarily call them n and m. So n and m are real numbers such that, now, if you were to, actually, by the way, let's do this. Let me just show you what happens if you apply FOIL to these 2 terms, just so you can see what this is all about. If you apply FOIL up here, you'll get x squared for f. The outer terms are mx. The inner terms are nx. And the last terms are nm. So you end up with x squared plus n plus mx plus nm. So that means that a is 1, b is n plus m, and c is nm. So now what you actually have here is 2 equations and 2 unknowns. These 2 have to be solved simultaneously. And so for this particular case, we can see, let's add this in here, that, all right, let's write it down again, x squared minus 3x minus 4 equals 0. And we know that this is b, a is 1, b is -3, c is -4. So b, or -3, equals n plus m. And -4 is the product n times m. So we have 2 equations and 2 unknowns. So probably the best way to go about this. Now, algebraically, there's a lot of things we could do. But I think our best bet is to try this. Why don't we take nm equals -4, and let's try to identify the factors of -4. And so they would be 1 and -4, -1 and +4, 2 and -2, -2 and 2. Now, we want to pick the one pair of factors whose sum is -3. So there's several combinations of numbers whose product is -4, there's only one of these in which the sum is also equal to -3. And that would be this one. Okay, so in other words, if you take the numbers 1 and -4, let's say that we decide n is 1, m is -4. Then n plus m is 3, and times m is -4. So that satisfies, oh, sorry, this is -3. So that satisfies the requirements. This implies that n plus m equals b, and times m equals c. So I can come back up here and say, all right, well, if that's the case, then my conclusion is that this expression equals x plus 1 times x minus 4. And so these are the factors of x squared minus 3x minus 4. All right, so let me move this to a new slide. So the first thing we want to do is prove it. We'll do a double check with a FOIL. We'll apply FOIL to these factors and make sure we didn't do something wrong. So we have x squared minus 4x plus x minus 4. Okay, and so we end up with x squared minus 3x minus 4, which is what we were expecting. Now, we're not done yet, though, because we have the factors. That's not what we really want. To find the solutions, what you have to do is set these equal to 0, both of them. And you'll find that x equals -1 and x equals 4. These are the solutions. So while the factors are up here, x plus 1, x minus 4, the solutions are x equals -1 and x equals +4. So if you were to draw a picture of this, it would look something like this. Okay, so now why don't we go to Symbol Lab for a minute and see what it comes up with. It should be able to draw this one. You know, sometimes it's it has issues, but this one, y equals x squared minus 3x minus 4. All right, so we'll draw the graph, and we're looking for the points where it crosses the vertical axis, the horizontal axis rather. So here it is. As we said, -1, 0 and 4, 0. So in other words, the two values that we need are -1 and 4. The values of x are what we're after. So either one of these will give us a value of 0. And in fact, if you want to double check again, here's another double check. If you plug x equals -1 into this formula or expression or 4, you'll get a 0 in both cases. So that confirms that we did this correctly. Now, I don't know if this thing is capable of doing the factors directly. It's possible. I've never seen that listed here anywhere. Oh, well, here's what it is doing for us. You notice how it says axis interception points of x squared minus 3x minus 4. These are the 2 points that we were interested in. If you notice, the 2 points where y equals 0, those actually are the solutions. So this actually also helps reinforce the idea that the correct values are -1 and +4. Okay, so if you need another double check, there it is. Those are not the factors, but at least they're telling you that you've chosen these correctly. All right, so that's good. It's good to have a double check. Nice. All right. Now let's see. Do I have another one? Yes. Let's try this one. So x squared minus 6x plus 8 equals 0. And so again, we'll write this out in the general form, which means that we're looking for two numbers. The product is 8, but the sum is -6. So let's find them. So we start by finding all the pairs of numbers whose product is 8. Don't forget the negatives. And we stop when we found the one where the sum is -6. And we're done. So what that means is that the factors are x minus 2, x minus 4. Now, we want to do a couple of things. First, let's prove it by using FOIL. So I've done that down here. X minus 2, x minus 4. Let's find out if they bring us back to the original equation. All right, so if you apply FOIL here, here's F, here's O, here's I, and here's last. So x squared minus 4x minus 2x, oh, what do you know? So we found the right factors, that's for sure. But what about the solutions? Well, this implies the solutions must be x minus 2 equals 0, x minus 4. And that just simply means that x equals 2 and x equals 4. So in this case, you have something like this. It crosses the axis in both cases where x is positive. So what we can do now is double check that these are indeed the solutions by plugging them in to this expression and making sure that we end up with 0. All right, let's do that. So we'll try x equals 2 first. We want to confirm that when plugged into the original expression, gives us an answer of 0. All right, let's do that. So you can see what I've done. I've plugged in 2 for x. Each x becomes a 2. Then I've got 2 squared, which is 4, minus 4, 6 times 2, which is 12, plus 8. And when you combine those, you do, in fact, get that 0 equals 0, which means we've done this correctly. Now let's try x equals 4. It's the same process. You just replace all the x's with 4s, and we're hoping to see that the sum equals 0. All right, let's do that. 4 squared minus 6 times 4 plus 8. 16 minus 24 plus 8. Oh, yeah, it works. All right, and then finally, of course, we want to check this out with Symbolab. Yes, let's do that. Why not? You have access to a very powerful tool. We might as well use it. So x squared minus 6x plus 8. Let's see what it looks like. And then we'll confirm that those 2 points are in fact the solutions. Okay, so yeah, here we are, 2, 0, 4, 0. By the way, I just noticed something interesting here. Oh, and here's the interception of 4020, right? But I just noticed there's a button up here somewhere that says solve for. Let's see what that does. X squared. Oh, x squared minus 6x plus 8 and it comes back. Oh, what do you know? Now, here you go. I didn't even realize it was capable of doing this. I just didn't know how to do it. Look what it did. Those are the factors, x minus 2 and x minus 4, that we just solved the hard way. Now, I noticed that they're doing it in a different way here. But, ooh, look at that. That's interesting. They're basically rearranging it. The first, oh, okay. But you know what? This requires us to correctly divide 6x into 2 and 4. I don't know how they would expect you to do that. I wouldn't use this approach. But anyway, so there it is, though. So you can confirm your work right there. And now you have that, but it gives us the solution, it gives us the factors. How do you like that? Excellent. Yeah, don't worry about any of this stuff down here. Oh my God. All right, now, with all that being said, we're not going to use the factoring very often. Most of the time, we'll just go ahead and use our old friend, the quadratic formula, which I know you've seen before. And when you see it, you're going to say, oh my God, I've forgotten all about this. But most people, I find, once they've memorized it, they never forget it. So when you see it, you'll say, oh, my old friend, the quadratic formula. Here it is. Oh, yes. Remember, b squared minus b plus or minus the square root of b squared minus 4ac over 2a. So remember, that's based on this notation. So the a, of course, means the coefficient of x squared. The b is the coefficient of x. C is the constant. And if you plug in these numbers, you should get the correct answers. Now, here, you're not dealing with factors. Whatever numbers you get will be the actual solution. So you don't have that extra step at the end. Once you're done with this formula, you'll have both solutions. So we're going to prove that by revisiting those last 2 examples and plugging in the numbers and seeing that we're getting 0, or the solutions that make this function equal to 0. All right, so let's go back and revisit the first expression we had earlier. X squared minus 3x minus 4 equals 0. So this means that a equals 1. Remember, there's an implied 1 here. That's why a is 1. B is, of course, -3. Don't forget the signs. And C is -4. All right, so we're just going to plug those numbers into this formula. All right, C comes in here, and then A shows up twice. And when you plug that in, now notice we have plus and minus, which means there's two values here. This is the equivalent of saying B minus and B plus all of this. So there's two different numbers here. So this is just the shorthand for plus and minus. It's just a little bit more compact than writing out two separate expressions. All right, so let's plug in some numbers. And again, we're simply replacing all the letters with the coefficients. Now, the tricky part is here. Sometimes you'll get a perfect square, and that means your answers will be there might be integers, they don't have to be. If the number under the square root is a prime, for example, you can't really simplify it very much at all, really. So you might get some very messy results. But here, because this will be a perfect square, we're going to wind up with these two integers. So by the way, one more thing, it's easy to make mistakes with the signs. Remember, this is negative 3, which gives us positive 3 here. Plus or minus the square root of 25 over 2, which of course is the same thing as 3 plus or minus 5 over 2. And now you see how I've broken this up into two pieces. 3 minus 5, 3 plus 5. And then you can take this one step further. This is actually minus 2 halves, comma, 8 halves. And that's where we're getting minus 1 and positive 4. So as long as you don't make any mistakes, which is easy to do with a formula like this, especially with the signs, you should get the right answers. Now, you can confirm this again by plugging these numbers into the original equation and make sure that they give you a 0. If not, then you've done something wrong. So this is one of those cases where you probably should double check everything, just because it's so easy to mess it up. All right, let's double check the second equation that we had earlier with the quadratic formula. So this time you can see A is 1 again, B is negative 6, and C is 8. And then also don't forget, like I was saying, factoring is not that hard when A is 1, but when it's different than 1, it becomes extremely difficult. And so in those cases, you would certainly want to use the quadratic formula because it doesn't, I mean, it works just as well no matter what the value of A is. All right, so let's see how that worked out. We plug in the numbers. And this time we end up, now here again, negative 6 becomes positive 6. And under the square root sign, this is positive 36 minus 32. So of course that's a perfect square. So we have 6 plus or minus 2 over 2, or rewrite this as 6 minus 2 over 2, 6 plus 2 over 2. And these two can be written individually as 4 halves and 8 halves before you convert them into 2 and 4. And we're done. Now, by the way, here's another helpful hint. If you make an algebraic error, and if you end up with a negative under the square root sign, that means you know something's wrong. Go back and double check your results. We're not going to consider any cases here where we have a negative square root. Okay, because that becomes an imaginary number, and we're not going to allow those in this class, okay? That's for pre-calculus. Here, we're only going to deal with real numbers. So if you end up with a negative square root, go back and double check your numbers. All right. So you know what, I'll tell you what, why don't we do this? Let me make up a new one just so you can get some practice. I have to be careful because I want to make sure that it works out nicely. Hold on one second. Yeah, we don't want any unpleasant numbers just yet. All right. All right, let's do this. Why don't you try find the solutions with the quadratic formula. All right, so once you take out a piece of paper, and because I know a little practice is always welcome, so let's do that. I'll give you a couple of minutes, and let's see what we come up with. All right, let's see how we did. So A equals 1, B is -2, C is -3, so we have negative B plus and minus the square root of B squared minus 4AC over 2A. So when you plug these in, you get -2 plus and minus -2 squared minus 4, 1, -3, 2 times 1. All right, let's see. I have to copy that into the next slide. All right, let's take it to the next step. 4 plus and minus 4. Now here's where we have to watch it. This is 4 plus 12 because there's a double negative here. So you can write this as 4 plus and minus the square root of 16 over 2. 16, of course, is a perfect square. So you've got 4. Oh, Mike, what did I do? No, sorry. What am I doing? That's not a 4. Okay, sorry about that. What am I doing? It's negative 2 is 2. All right, much better. So yeah, like I said, it's so easy to mess this up. So you're going to have 2 minus 4 over 2, comma, 2 plus 4 over 2, minus 2 over 2, comma, 6 over 2, minus 1 and 3. So this is what you've got. Those are my solutions. All right, so hopefully you all got that. If not, go back and double check. Most likely you made a sign error, but possibly like I did, you copied the wrong thing or did something wrong. It's so easy. But luckily we can double check it very easily. You can plug these numbers into the original equation. Although in our case, we also have Symbolab, which we can confirm it with. In fact, why don't we do that real fast? X squared minus 2x minus 3. What happened to it? There it is. So first the graph. Wait. Oh, I see what I did. This one, it still says solve for. That's why it's not showing up the graph. So in other words, it's coming back here and saying you could factor this, but the actual solutions. Well, that's weird. Okay, I'll tell you what, don't use the solve for function unless you want to factor it. I think what we needed to do is this. So I'm still learning this thing. All right, so here it's, yeah, wait a minute. 3, 0, negative 1, 0. All right, that's what we have. Let's do a graph. There we go. Negative 1, 0, 3, comma 0. So that proves that we did this correctly. Excellent. Now, it doesn't always turn out to be the case that the answers are integers. It happens a lot, but don't assume that if you've got a messy result that it's wrong. So, you know what, let me try another one here that might not work out so nicely. How about this one? 3x squared. Okay, let me just double check one thing. Oh, it's a good thing I checked. Sorry, change this to 1. We almost had imaginary results. All right, give that one a shot and see what you get. All right, now you notice there's a 3 in front of the x squared. When a is 1, you know, the results tend to be nice. Like if it's an integer or a very simple fraction. When you start getting other numbers for a, that's when these can get very messy. But as long as it's not an imaginary solution, we'll be okay. All right, so give that one a shot. So in this case, A is 3, B is -4, and C is 1. So we have okay, so -4 plus and minus -4 squared minus 4, 3, 1 over 2 times 3. All right. So it's not going to be integers, but it won't be too messy. All right, so we have 4 plus and minus 16 minus 12 over 6. Okay, so that's going to be 4 plus and minus 2 over 6, which means 4 minus 2 comma over 6 comma 4 plus 2 over 6, which means 2 over 6, 6 over 6, or simply 1/3 and 1. All right, well, that, they're not both integers, but they're pretty nice. Sometimes these can get very, very messy, and they can involve a lot of square roots. So anyway, so once again, let's double check our old friend Symbolab to see what we've done. 3x squared minus 4x plus 1. So first things first, let's solve for it. Well, actually, no, let's look at the graph. So we have 1/3 comma 0 and 1 comma 0. Perfect. That's what we have. And let's say, you can tell by these two intercepts. And that's all we need. Okay. The solve for, as we've discovered, just gives us the factors. We don't really need the factors here. Ultimately, all we really care about is the solutions anyway. Now, here's an interesting one. This is going to take a couple of minutes. This is a real world example. And so imagine here's a carpenter. He's trying to build a rectangular picnic table. And due to space constraints, the length must be 2 more than the width. So here's the length. Here's the width. So if, let's say, the width is x, then the length is x plus 2. Now, you might remember that the area of a rectangle is the length times the width. And in this case, that would be x plus 2 times x. The area of this table must be exactly 35 square feet. So that means that x plus 2 times x equals 35. Or x squared plus 2x equals 35. And if you notice, all I have to do is subtract 35 from both sides, and guess what I have here? A quadratic equation, which means I can solve for these dimensions by using the quadratic formula. So I'll tell you what, once again, just because we could use some practice, why don't you go ahead and calculate the dimensions? All right, but this one has a little twist. You'll see at the end what I mean. All right, so give this a shot. And let's see what we can come up with. Okay. So this means that A is 1, B is 2, and C is negative 35. So if you plug those in, now it's already been done here, you'll see that you get -2 plus or minus the square root of 2 squared minus 4 times 1 times -35. And so we got a lucky break here too, because if you look at this, you'll see, of course, that 144 is a perfect square. So we've got -2 rather, minus 12 over 2, comma, -2 plus 12 over 2, or -14 over 2 and 10 over 2. So these are the two solutions. Now, if you drew out this parabola, you'd see that, yes, indeed, it does cross at these 2 points. Now, here's the question, though. Can the width of a table, X, remember, is the width of the table, can it be negative? And the answer is no. So in other words, even though X technically is -7 and +5, because this is an example of area, we can discard this solution and end up with X equals 5. And so that means that our table has a length of 7 and a width of 5, which tells us that not only is the length 2 feet greater than the width as we required, but the area is 7 times 5, which is 35. That's exactly what we needed. So the correct dimensions are 7 by 5, which gives us the desired area of 35. So sometimes we run into this in math. The solutions are restricted to being positive or negative, whatever the case may be. So even though there's technically 2 solutions, only one of them is valid. And so you do run into this, and it just means discard the incorrect, the one that doesn't make sense. Obviously, -7, how can you have a width of -7? Well, maybe if you could go into another dimension, but I don't think that's going to happen here. So that was it for quadratic equations. And guess what? That's also the end of chapter 6. So now, like I said, we're ready for the problem set. And we'll do that on Monday. And then on Thursday, we'll do the sample midterm. Now, if the sample midterm runs long, we can finish it the following Monday. But at least we can start it on Thursday. And then whenever we finish the sample midterm, you can have a week after that to do the actual midterm. There's no hurry. We're in very good shape with time. So in the meantime, it turns out I actually did find a video. It's hard to imagine, but there's a video that I found about the quadratic equation. It's a very good video, so I want us to see it. So let me go over to Moodle and get the link. All right, so let's get that. Let's see, do I have it open? Here we go. And the link we're looking for, well, what do you know? It's called quadratic equations. So as usual, I'll send you the link and we'll check it out. Now, by the way, you can tell already you can see on the screen, this one, let's just say that the tone of this thing can get a little silly. All right, so just, try to overlook that. It is actually a very good video, although you might look at it and say, what is going on here during certain parts of it? So let me just send this over. Let's see what is going on. Oh, here we go. No. Now this is, oh, I forgot. It crapped out on us. Remember this happened like, oh, for God's sake. Yep, it's dead. All right, so here's what we're gonna have to do. I'm gonna have to unfortunately reboot my computer or else reboot this program. Just like the last several times, there's just, I don't know what's going on here, but we have to stop for a minute so that I can get this thing up and running again. And when we do, I'll send you the link. Okay, so first we have to stop Zoom from recording, and then we can pick it up again in a couple of minutes. So let me just take care of this. Yeah, it started to get peculiar there. I could tell it was getting ready to do something it shouldn't have. All right, so I'm going to have to unfortunately reboot the whole computer. So I'll be back in a minute.